And welcome, Space Weather Types, to the Daily Space Weather Show. Congratulations on realizing the channel exists and so on. We've got a fairly quiet sun here over the past 24 hours. The action has mainly been from these series of sunspots in the northeast. There was an M-class intensification, which we have captured in that 24-hour video from Solar Dynamics Observatory. And here's the equatorial zoom to show you the full picture. Well, not quite the full picture, but the polar regions have been truncated for your viewing pleasure. That's 193 angstroms running 60-minute difference, along with 304 angstroms ionized helium. Classic wavelengths there, and there is the full disk view. Don't worry, we've got plenty more spectacular solar imagery for you. First, the SDO continuum. And we have seen a little increase in sunspot number since yesterday, but it's been pretty minor. No new major regions there rising over the eastern limb. No new regions forming. And so things have been largely stable. There's colorized magnetogram from SDO as well. And let's take a brief look at volcanoes. Do I consider volcanoes part of space weather? Well, the answer is absolutely not. The reason that we cover it is because there is demand for volcano coverage. So those are the currently erupting volcanoes. And here is the list of the erupting volcanoes. One did have its alert level raised. We'll get to it. And I'm not going to just call out the name of every volcano here on the list. If anything extreme is going on, I will let you know. Luotobi has increased its alert level to a level 3. Siaga, due to seismic activity. So those are the volcanoes that are currently erupting. And let's move on to earthquakes next. Earthquakes. It's been pretty calm for the past 24 hours. There are the past 90 days, following that 7.5 magnitude event at Japan. These are the quakes of a 5 and greater magnitude. Aftershocks continue at Japan with this 5.4 this morning. Indonesia had a 5.0 at 4:45 this morning, Universal Time. So pretty chill as far as earthquakes go here for the past 24 hours. Mid-Atlantic Ridge had a 5.0 there. Quite close to the equator. And Philippines had a 5.0, and that is the earthquake list. Let's get to some more space stats. The 10.7 centimeter radial flux now down there, back up to 142. 142 is the 10.7 centimeter radial flux number, I believe. There is the 1 year graph to contextualize that. The black line there is the radial flux. Red line is the sunspot number. And Space Weather Enthusiast Dashboard actually forecasting some geomagnetic storm conditions tonight from a possible coronal hole high-speed stream and CME impact. I'm not seeing it, but that's NOAA's forecast. It looks like some false positives likely to show up there on NOAA's forecast. So we forecasted that CME to be a miss, and we also forecasted the coronal hole high-speed stream to be a miss. It's so late now that it's not likely to show up at all. So disagree with that format, not expecting, disagree with that forecast, rather, not expecting geomagnetic storm conditions tonight. But hey, tune into tomorrow's daily space weather content to see if I was correct. Next Earth's magnetic moment from space for the past 4 hours. It's our Geospace Magnetosphere movie. And we did see a brief period of geomagnetic unrest as we premiered last night's daily space weather video. But it was short-lived, and it was mainly associated with magnetic field orientation. The past 4 hours have been pretty chill. Here's Earth's magnetic moment from ground level. That's magnetic flux density, the units of which are nanotesla. And again, we're currently experiencing geomagnetically calm conditions. KP index at 1.33. That's the average of global geomagnetism. 1.33 is the KP index. Again, we did reach KP4, unsettled conditions, just before midnight last night. Next, some real-time solar wind. Here's the ACE. The ACE showing a slow and diffuse solar wind. We'll call out the stats from the Discover as there is a more complete data set there. Discover currently showing about 6.5 protons per cubic centimeter. For the solar wind density, solar wind velocity here, just over 400 kilometers per second. Pretty unremarkable for the past 24. GOES magnetometers here are smooth for somewhat of an extended period there. So no major geomagnetic storms here for quite some time. And let's move on to our top view ecliptic plane field plot. We do see some changes happening here. A coronal hole suddenly opening up right in there. You see that South Pole oriented coronal hole there? It will show up in some other imagery as well. It looks like a South Pole heliospheric magnetic sector is on the way here. And it could be there as early as tomorrow. It could suddenly evaporate too, folks. Keep in mind the magnetic environment can change with basically no warning. Here's our line of sight field plot. And you'll see that B field over there on the eastern limb suddenly swing down toward the southern heliographic region. That is what we're talking about. Some rapid changes happening there with the opening of a coronal hole. So that's our line of sight field plot showing you a whole bunch of different magnetic data sets at once. The photosphere, as well as the corona's magnetic field and the B field. Here's the B field once again shown in blue. Coronal hole magnetic fields. Coronal holes, really, the coronal holes themselves, shown in red for south and green for north. So right up there in the northeast, you will see a coronal hole opening up there, right in there. You can see the B field moving there in unison with that. So that may bring a South Pole magnetic sector to Earth as early as by the time we make this video tomorrow, although I would suspect it will take a little bit longer than that, probably more like 36 to 48 hours if I had to guess, which I certainly do not. And let's bring up some more imagery here before we get to coronal holes. Here is another 24-hour video. That's SDO 171 angstroms running difference and 304 angstroms. And here come coronal holes. So there's my favorite coronal hole wavelength. That's 211 angstroms from Solar Dynamics Observatory. And so this coronal hole up here, this one here is South Pole oriented. So that's south. These are south. This one down here is south. And these are North Pole coronal holes. That's what's going on in the heliosphere. Let's talk about some more energetic stuff. First, what's going on in the photosphere? A little increase in sunspots here since yesterday, but it's modest. So sunspot number now up to about 70, 75 maybe, something like that. I'll say 73. 73 is the current sunspot number. And here's our flare probability monitor and scoreboard. Most likely place to see a large flare remains sunspot 3536. So we've got several here that are not named yet. They are probably already counted at the Royal Observatory of Belgium sunspot number. But that area right there, 3536, is certainly the most likely place to see large flares moving forward. And here's SDO continuum for the past 24 hours. Again, mostly stable here. And also keep in mind, folks, once those sunspots get counted, there are going to be a lot of sunspots added to the sunspot number. Here's why. We'll zoom in a little bit closer. And there you can see great detail there. A lot of small umbrae there are around both of those sunspot groups. So, I mean, sunspot number is going to be over 100 the next time it gets updated. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, sunspot number is going to be over 100. But that's the current situation. Great close-up there from Solar Dynamics Observatory's HMI instrument. And let's cut back to energetic particles and flares. So we did have a proton event here. So there's been an ongoing proton event which started on New Year's Eve, actually. The sun putting out some fireworks there. And the proton flux has risen now, so we are seeing some polar radio blackouts associated with those relativistic particles. So those are currently orbiting Earth's magnetic field lines around the poles. And here's a great indication of what's going on there. You will see some polar radio blackouts. This is our deabsorption region imagery. It's showing attenuation of the D layer of the ionosphere. So those protons are putting out radiation, which is causing the D layer to effectively not exist at the poles, especially the south polar region. Here you'll see that proton event slowly setting in. And you'll see the polar regions here lighting up in just a moment. Just in the past few hours, just causing some ongoing polar radio blackouts. And those might last for an extended period of time, folks. They have been known to last for like 5 days at a time sometimes. There you can see that polar radio blackout, especially at the south polar region. And it still looks like the proton flux is on the uptick. So there's a great indication of the earthly effects of solar activity. So it may have reached a peak here. We have seen a drop in the past couple of hours or so, but I wouldn't count on it. If I had to guess, I would say that we've already reached the peak, though. Anyway, X-ray flux here showing one M-class flare, and M1.15 was the peak flux right at 1830 Universal Time this evening on January 2nd, 2024. And here comes some fantastic images of the closest star. That's 94 angstroms plus 131 angstroms, 60-minute running difference. And let's get all up and personal. Here's the equatorial zoom. There still is some possibility of a large flare on the western limb, but this is definitely the place to watch. So sunspot 3536, which is south of the Earth scale at the end of that video. And it looks like there is another active region rising up here. So that looks like a new sunspot on tap by the time tomorrow's video comes out. That looks like it's ready to peek over the limb at any moment here. And let's chill out and take a look at a star chart. Chill out, everybody! Everybody chill! Everybody chill. That's what's going on overhead Lehigh Valley, Pennsylvania. If you want to make your own star chart, well, head to skyandtelescope.org, put in your location, and the largest object visible to the naked eye has just risen over the horizon there. It's Betelgeuse. Yeah, the red supergiant star. That's so big if it was centered where the sun is, you'd be inside of it. And of course, if you want to find Betelgeuse, just find the very distinctive belt of Orion, follow the middle star perpendicular to the belt, and you will have a perfect perpendicular line there pointing right at Betelgeuse, the largest object visible to the naked eye. Next, our solar system forecast. That is where things are today. That is where things will be in 1 week for heavenly bodies on the 9th. A crescent waning moon will be in place. And next, our astronomy photo of the day. You're wondering what that is. Is it chemtrails? Is it contrails? Well, not at all. It's the rocket plume from the Falcon Heavy, superimposed on the full moon. Falcon Heavy. On today's apod.nasa.gov, the astronomy picture of the day. apod.nasa.gov. If you want to check it out yourself, that's where it is. Great photo there by Stephen Maddow. Or is it Maddow? I don't know. Anyway, next it's time to move on to coronal mass ejections. And we've got some. Some people might think that they're earthly directed. I don't think they're earthly directed. See that one there? It looks like it's a partial halo. Guess what? It's not earthly directed. Anyway, rather than let those play through, let's just show closer images here. And we're going to let the C3 catch up just a moment here. All right, so we've got the C2 on the left, a little bit ahead of the C3 on the right. Those are our coronagraphs located at Lagrangian point 1 on the SOHO spacecraft. SOHO-LASCO C2 coronagraph on the left, SOHO-LASCO C3 coronagraph on the right. And again, a number of CMEs have occurred. I just don't think they're earthly directed ones. So let's take a look at our custom coronagraphs that might be more obvious. So those are 24-hour videos. Let's get a little bit closer here. We've got the SDO 304 angstroms synced up with the LASCO C2 and C3 there. And again, I do believe those CMEs are not earthly directed. So the one you see kind of coming out of the west there, that's somewhat on the far side. It came from, you can see it up here actually. Does not look like it is earthly directed. So that's my story, and I'm sticking to it. I'm interested in facts. And there is another 24-hour video. That's the same thing. That's 304 plus 193 angstroms running difference, 60-minute running difference. And that is where our coverage ends for custom imagery. So next we're going to move to filaments. We still do have some filaments, but a much lower number than we had a week ago, for example. Some filaments over there in the east that could perhaps be worthy of naming. You might even be able to make the argument that that's only one filament. But that one could use a name, I would say. And if you don't follow us over on Twitter, I just might name that one the Barack Obama filament. So, I don't know, maybe you're a fan, maybe you're a critic, maybe you don't care in the slightest. It is 2024 after all, so the in-style thing to do will be unplugging from politics entirely. Oh, what a disaster. And before we get to bonus features, here are the past about 3 hours from the GO 16 SUVI. We did have some sweet CMEs throughout the day today, but just not earthly directed ones, so terribly sorry for all of you Aurora hunters. I don't think it's good news for you. And let's move on to bonus features. Our first bonus feature is charging hazards. We ain't got none. It's smooth sailing. No high energy electrons building up inside of spacecraft. No low energy electrons building up on the outside of spacecraft. That's the scenario. GO's electron flux here is kind of in a normal operating range. A bit on the low side, if you ask me. So that's the past 3 days. They're the past 1 year from Solon.info of the relativistic electrons, measured using radiography from the geosynchronous orbits of the GO 16 and GO 18. It's measured at the F layer of the ionosphere. So there's the forecast model, and NOAA is expecting, that looks about right for the forecast. The next update here should be coming in the next few hours. The green boxes are the forecast, the yellow diamonds, the observation. Next, it's time to look at the ionosphere. So here it is. We'll be looking at the F layer, and feel free to pause the video in this frame if you're not familiar with distances in kilometers. This is about 300 kilometers. The F layer, which is looking quite normally. Nothing to write home about there at all. Here's the anomalygram, anomaly in megahertz from a 30-day median. You won't see very many anomalies in there. Things are fairly steady at the bridge between Earth and space. Next, it's the WAM, the whole atmosphere model, the global ionosphere nowcast, depicting total electron content on the left, along with the anomaly. Maximum usable radio frequency on the right, along with anomaly. To benefit all of you GPS and radio users. That's what's up with the ionosphere. We'll close out space weather with the latest high-res imagery. So So there's the continuum. Here is the magnetogram. We're just going to show this region right here because it's where it's at. Where it's at. It doesn't need 2 turntables or a microphone. That is a fair number of umbre. Anyway, it's time to recommend that you visit our links like smashomash.com. Before we get to our meteorology segment, help out the channel. We'd prefer to continue to exist, remain publicly visible, and free for all to view. So visit our links. Perhaps become a member of the Smash team. Support the channel by pressing the like button, pressing share, leaving a comment, picking up some merch, visiting our other links like our Amazon storefront, our Hemp Lucid link, etc., etc. Smashomash.com, launched in 2019 in response to the suppression of people's perfectly legal speech. So press the like button if you're new to the channel. Press subscribe, or your soul could be cast into an ever-deepening and darkening abyss of doom, destruction, and kiss merchandise. Yes, kiss merchandise. Imagine having to live it through eternity with that. How would you like that? So press the like button, lest thy soul be inundated with Gene Simmons masks. And perhaps a Gene Simmons soap on a rope. Is that what you want? Of course not. So press the like button, you insane fools! If you're new to the channel, press subscribe, though. Seriously, you may want the world's most comprehensive daily space weather content in your feed. We've noticed that Elon does not watch the channel, which is why he destroyed a bunch of Starlink satellites last year in 2 years ago in February. Should have watched the channel. We forecasted that geomagnetic storm. Shout out to Tamitha Scove, who also forecasted that geomagnetic storm. Cheers. Oh, yeah. And it's time for meteorology. So first thing we're showing is the world's largest waves. Can you guess where they are? Let us know in the comments. Leave us a guess. Where do you think the world's largest waves are? Well, we're going to tell you here in a minute, but first, leave a comment and tell us where you think there are some 46-foot waves right now. Yeah, 46-footers, folks, the better part of 50 feet. Those are some big waves, and they are in the North Pacific south of the Aleutian Islands. So there you go, the world's largest waves right in there. Dag, those are indeed some stormy seas. So that is significant wave height and surface winds. The shading is the wave height, and the animation is the surface wind velocity. So that's what's going on. I'll show you the rest of the oceans. Look at how calm it is in the Southern Ocean. Look at that. That is by far the world's stormiest ocean region. And let's blast through the rest of meteorology. Surface winds of the east are looking like this. Jet streams of the east are like that. Jet streams of the central world shown here. Shout out to our viewers from all around the planet. Surface winds shown here. Some windy conditions in the English Channel and indeed in the North Sea right now. So some bad times for Viking raids. Surface winds of the western world looking like this. And here are the jet streams of the Americas. Here are clouds and fog for the Americas. As once again it clouds up in Brazil. The sun sets, the clouds come out, and the freaks come out at night. The freaks come out at night. The freaks come out at night. And here's a close-up of this low that's been loitering off the coast of Delaware. A bunch of low clouds there forming on the tail end of that low. As it slowly makes its way south toward Bermuda. Kind of a strange path for that low-pressure system to take. And it all has to do with the jet stream being really far south right now around the western world. So that's what's going on. Next, the world's lowest pressure. Guess where that is, folks? Just take a guess. Look at that, 938 hectopascals. That is like hurricane-level pressure south of the Aleutians. So regular viewers are probably well aware that low pressure is associated with the largest waves when it's over the ocean. And that is one heck of a nasty low pressure there. That is a bulky low. 938 hectopascals. Dag. The world's lowest pressure there. Right now in U.S. territorial waters. Next, our weather.gov map. That is where things are lit up. We'll scroll down and show you the key as blizzard warnings continue for the state of Alaska. If your location is lit, click your location. Those are too many counties for us to cover. However, we will show you some forecasts. So first, the GFS 72-hour temperature, pressure and precipitation, Pressure and precipitation for the next 72 hours. And some very strong storms here are going to form right along the Texas coast and then slide toward Louisiana. So that's going to create some extreme weather. There could be a tornado watch or warning happening there. Look at that low that forms. That is a serious low. And some serious snow coming to California. We'll get to it. First, not first. Straight to the snow forecast. There you go. Accumulated positive snow depth change in inches. Some parts of California there pushing 2 feet. Shout out to Smash Staff's mom once again. Nevada will be almost fully covered there. Anyway, 72-hour GFS accumulated positive snow depth change in inches. Next, total accumulated precipitation in inches. Same model, the GFS 72-hour. As some of that precipitation will be in the form of rain. But mostly snow there, actually. We'll also show the jet stream, which, like I said, is very, very far south. And it's going to be staying there for the next 3 days or so. That's the 250 millibar wind speed forecast based on a 72-hour GFS model. So there you have that. And here is our temperature anomaly forecast in degrees Celsius. The same model, the GFS 72-hour. We show 72-hour forecasts because they tend to be accurate. Yeah, mankind is basically unable to forecast the weather beyond 3 days. And so we show 3-day forecasts because they are, the majority of the time, quite accurate. Any channel showing you a forecast longer than 3 days is probably doing you and their own credibility a disservice. Next, lightning. And there's where the strikes have been associated with that low hanging out in between Bermuda and New Jersey. And let's see if we have any current strikes. And indeed, we do have some lightning here in Texas. So some recent strikes there around Austin and San Antonio. And also some here in the Atlantic. Next time you hear thunder, highly recommend you check out lightningmaps.org. If not, it's not going to hurt my feelings. I definitely won't care. We'll close out the daily space weather video with your Earth weather. Here is vertical motion of the air column, Doppler radar. That's what Doppler shows. Ground-based systems. Space-based systems that show clouds and fog, even at nighttime. 3.9 micrometer infrared radiation, the shortwave radiation map. And here's the water vapor map. You can see that atmospheric river once again making its way from the Pacific into the Pacific Northwest, bringing some more moisture. The Pacific Northwest, pretty doggone moist. Anyway, hopefully your dog's not gone. There's the U.S. Doppler. There is the clouds and fog view. There is the water vapor map. And here is me closing this thing out. Thanks for tuning in to the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.